Hi, very good day to all. Before proceeding into our section, let me introduce about our platform, what we are offering for you guys. Learners Note is an online solution for providing a better way of education among our students. I am Chinju, your mathematics teacher here. So today I want to discuss about application of integration. Why we are studying integration? What is the use of it? We are mainly using application of integration for finding area under the curve. We can calculate the area under the curve by using definite integral. So, before proceeding into our core content, let me introduce about the symmetry of a graph. So, if you are saying symmetry about the x-axis, you will get a figure like this. So, this equation is y square is equal to 4ax. In this equation, you can see the power of y is an even number. So, if all the powers of y in the given equation are even, then the curve is symmetrical about the x-axis. For example, you can see this is the required area. Okay, this is also the area under the curve. So, if it is symmetrical with respect to the x-axis, I will write, okay, when we are integrating, we are using integration for finding the area. So, we can write it as integration 2 into y dx. Okay, this is the thing we are finding, we are using for calculating the area, because this area which is same as that of this area. So, we can, for calculating the area, we can use the equation 2 into integration y dx. So, this is about the symmetry about the x-axis. If you study the symmetry, we can save a lot of time for the calculation and all. Then next is symmetry about the y-axis. This is the y-axis. You can see the y-axis here. So if you get a equation like this, x square is equal to 4ay. When you get this equation, you have to check the power of x. If the power of the x in the equation are even, then the curve is symmetrical about the y-axis. For that, we can use the equation. We can use the equation as 2 into x dy. Okay, x dy. This is the equation you can use for calculating area under this curve. And for this also, by taking this equation also, you can you can save a lot of time. Then, this is a circle. Okay, this is the equation of circle. But we cannot say this is symmetrical. This curve is symmetrical with respect to the y-axis and with respect to the y-axis. This figure, this is symmetrical. This curve is symmetrical about the axis x as well as the y-axis, because we can see we will get an equation like this. So in this, when you check the equation, you can see that the power of x is an even number, the power of y is an even number. So this curve is symmetrical about the axis of x and y respectively. This is the way in which we can check the symmetry about a curve. Then, this is a standard equation we are going to use for calculating area under the curve, where area can be calculated by using the formula integration a to b f of x dx, then integration a to b y dx. So here we are using integration with respect to, we are calculating the area under the curve with respect to the x-axis. With respect to the x-axis means this is our x-axis. So we are taking the upper limit and lower limit like this. For finding the upper limit and lower limit, we are taking area under this curve. This is our curve. This is you will get the equation for the curve. Then this is our x-axis. So we are taking the area with respect to this x-axis. So we can use this equation for calculating the area. Then in this figure, what you can see is, this is our function, this is our curve. So when you see this curve, we can see that the curve lies under the x-axis, So when we integrate this equation, with respect to the x-axis, you will get a negative area. but area cannot be negative, so that we can take the modulus. Okay, and then here I am using, here I am finding the area under the curve with respect to the y-axis. The vertical line is our y-axis. Then I am going to calculate the area with respect to the y-axis. So I am integrating from, this is a straight line and this is also another straight line. Then for finding the limit of the integration, we are taking two lines, straight lines, and we are integrating from A to B, and we are taking area with respect to the y-axis, and we are going to use this equation A into B f of y dy. So I told you already, this is the 5 steps we have to follow. Thorough with these 5 steps, we can simply solve all these problems. The first step is, when you see the question, at the moment itself you have to draw a figure. For the CBSE and all, in the answer sheet itself, they will attach a graph paper with it. So if you want, you can use that graph paper. Otherwise, you have to make a rough figure. The first step, when you see the question from this chapter, you have to draw the figure. Then the second thing what you have to follow is, you have to shade the relevant region and check for symmetry. Check for symmetry means, if I have a symmetry like this, this is our x-axis, this is our y-axis. If we have a symmetry like this, we can take, the area under this curve, we can calculate the area under this curve with respect to the x-axis. So this is symmetrical about the x-axis. So we can save our time by taking the symmetry. That's why we have to check the symmetry, check for symmetry, if any. So it will save our time. So first one is draw the figure, and second one is shade the required portion. Then the third point is find the point of intersection to get the limits of integration. We have to integrate the function by finding the limits. Okay, we have a lower limit and upper limit. So we need to find this limit of integration. For that, we have to solve the equation. This is applicable when we have to find the area between two curves. Suppose, if you are getting a curve like this and curve like this, so this is the required area. So if you want to find the area between this curve, this is our required portion, and for getting the limit, when getting the point of intersection, we have to solve this equation simultaneously. If we solve this equation simultaneously, we will get the point of intersection. By using the point of intersection, we can integrate. Okay, that is the third step we have to follow. The fourth step is express the terms in terms of dx or dy. If you are integrating with respect to the x-axis, we have to represent terms with respect to the x. Then if you are integrating with respect to the y-axis, then we have to represent express the terms with respect to y. So mainly we are using we will express the area in terms of dx. Then the fifth step we have to follow is solve the equation. So because we have studied so many formulas for solving the integration and all, we can use this formula for solving. So this is the first question I want to discuss with you guys. So this is a curve. Okay, the equation for this curve is s square plus y square is equal to 1. This is the equation for a circle. Okay. So this we cannot find any symmetry for this, because this is symmetrical as well as for x-axis and y-axis, because this is the first curve they are given. And the second curve which I am taking is this straight line. So the area, using integration, we have to find the area of the region, the shaded portion. This is the area we have to find. Okay, for that what we need to do is, first of all, we have to find the we have to draw the figure. So you will get a question like this: x square plus y square less than or equal to 1. So that first of all you have to draw the figure. That is the first step which I have told you. So you have to draw a circle. You have to draw a circle with the radius 1. Then next equation is x plus y equal to 1. That means that is the equation for a straight line. You have to draw the straight line. After drawing those two curves, we have to identify the required area and shade the relevant area which you want. Okay, this is the required area. So I am going to calculate the area and between these two curves. So the required area is the shaded ACBDA. This is the required area. For getting this area, what we need to do is we have to find the area under this curve. We have to find the area under this curve. The first curve is our circle. So for finding the circle, I am integrating with respect to the x-axis. So I have find the point of intersection. These are the point of intersection. Okay. So I just found out the point of intersection. The point of intersection is A and B. I can find the point of intersection as A and B. Then after getting the point of intersection, I have to integrate. So the lower limit is 0 because I start integrating from here to here because I am taking the integration with respect to the x-axis. For that, I am taking the lower limit as 0 and upper limit as 1. Then I am integrating this portion. So when I am taking the first curve, the required area is this one. This is the area. Okay, because when we integrate the curve, integrate the first curve, that is our circle. So you will get the area under this curve. That means the required portion. Okay, AOB. So for that, I just found the lower limit and upper limit. After that, I have expressed all the terms with respect to x. Okay, in terms of x, I have represent the equation because you are getting an equation like this: x square plus y square is equal to a square. Here a square is 1. A square is 1. So we have to represent y square, that is 1 square is 1, 1 minus x square. Then for getting y, you have to take the square root of 1 minus x square. So I have represent all terms in terms of x, Then I just integrating by using the point of intersection, that is 0 to 1. Then I just take the next curve, that is the line, that is the second curve. So I am also writing the equation of line, that is x plus y equal to 1. Here also I have to write the equation of y in terms of x. So you will get the equation as 1 minus x. Then I just take the limit of integration is 0 and 1. Then I am just integrating it. After integration, you will get the, when you apply the upper limit and lower limit, which all you have studied already. So you will get your areas pi by 4 minus 1 by 2 square units. Don't forget to write the square units because area usually expressed in square unit. This is about the solving method and all. For finding the point of intersection, we have to solve these two equations simultaneously. After solving this equation, all those things you have studied earlier. So when you solve this equation, you have to get the point of intersection as x is equal to 0 and x is equal to 1. Then we can apply that as upper limit and lower limit and start integrating. Then you will get the required areas pi by 4 minus 1 by 2 square unit. That is a unit of area. And this is the second question. Here also, when you see this equation, you can understand that this is the equation of a circle. Okay. So, the a square is 32. A square is 32. For that, you can find a by taking the square root of 32. So, square root of 32 can be written like 8 into 4. Then 8 into 4 can be again written as 4 into 2 into 4. So, 4 root 2 as the a. You will get a as 4 root 2. So, we need to calculate the area of the shaded portion. So, this is the curve, the first curve which you got, x square plus y square is equal to 32. And the second curve is, that is the equation for a straight line, y equal to s. So, this is the second curve. So, I need to calculate the area between these two curves. For that, this is the portion, this is the required area we need to calculate. For that, we have to find the intersecting point. For finding this intersecting point, we have to solve these two equations, x square plus y square is equal to 32 and y equal to s. When you solve this equation, you will get this point of intersection. This is 4 and 4. And you can calculate the area with respect to the x-axis or y-axis. So, this is the point, okay, which is equal to 4 root 2 comma 0. You can write like this also. So, After finding this point, we can integrate. Okay, the same method. Okay, after solving this, you will get the point of intersection. Then when you solve the equation, because after finding the required region, you can express all the terms with respect to x, I mean in terms of x. Then after integrating it, you will get the area as 4 pi. That is the area. Okay. Then here you can see in the next question, what you can see is, the equation of the curve is 4y is equal to 3x square. You have to understand, this is the equation for a parabola. So you have to draw the parabola by putting values for an x and all. After drawing the parabola, you have to consider that is the first curve. Then 3x minus 2y plus 12 equal to 0. That is your second equation. Okay, after putting some values for x and y, you have to plot 3x minus 2y plus 12 also. Then after solving these two equations simultaneously, you have to find the point of intersection, and after drawing this figure, you have to shade the required portion. This is the required portion, so you have to find the integration over this portion. Okay, for that I am finding the intersecting point. Then if we are taking curve, finding area with respect to the x-axis, you have to draw like this, and you have to start integrating from this portion to here, from -2 to 4. Okay, that is the limit of your integration. So here also I just solved the equation for parabola with the equation of line, and I got the point as 4 minus 2, intersecting point as 4 minus 2. You can see the point here, 4 minus 4, 12, and this is the second intersecting point, that is -2 and 3. By solving these two equations, you will get the point of intersection. Then for finding the required area between the curves, you have to integrate the y line and the equation for parabola also by taking the limit. Okay, lower limit and upper limit. My lower limit is -2 and upper limit is 4. After integrating, you will get the area is, required area is 27 square unit. Till now, we have discussed about how to find area between the curves. These are the important questions you can expect for your public examination. I hope that you have thorough understanding about the topic which I have discussed today. Learners Note help you to acquire knowledge through our Learn by Doing methods. Please support us. Visit us at www.learnersnote.com, where you can see plenty of updated videos and experiments which is linked with your syllabus. Hoping to meet you all through our Learners Note interactive platform. I am Chinju, your mathematics teacher, signing off today. Have a nice day. Thank you.